Today we're doing 7-4 day 2. They're calling this day 2 because it's still dealing with transformations of quadratics. On Friday we talked about the two different forms of writing quadratics, one of which we call the standard form. The standard form is that a little bit more typical ax squared plus bx plus c. And you primarily use the standard form when you are factoring, or this is also used for the quadratic formula, which we'll be doing in a couple of weeks. Quadratic formula is, that negative b plus or minus big square root b squared minus 4ac all over 2a. We'll do that again. So our vertex form, this is what we did on Friday, is used to graph. So this is the a open parentheses x minus h close squared plus k, where a here is going to be the same number as it was here. So when we go back and forth between the standard form to the vertex form, this number a is not going to change. The benefit of the vertex form is, of course, that we are able to graph the vertex form pretty easily. So it's used to graph the parabola. So what it is that we're doing today is when the equation of a quadratic is written in standard form, it is necessary to complete the square to find the coordinates of the vertex. So we're completing the square to write it into vertex form. So I have some steps that we're going to write down and then do a couple of examples. Okay, so step 1. Separate the C while GCF, I'm going to make up a word, GCFing, so out the A. And then also put in blanks. Okay, so let's recall these numbers. A is 3 here. A is the number in front of x squared. B is negative 12, and C is 36. So the first step, separate the C while GCF out the A. So the A is 3, so I'm going to say 3 open parentheses. And what I am GCF the 3 from is just these first two terms, because I'm going to separate this C value away from it. So if I'm pulling out a 3 from these two terms, inside of this parenthesis, I will have x squared. 3 times x squared is 3x squared, and 3 times minus 4x is that minus 12x. We're going to put in a blank here, and we still have plus 36, and I'm going to put in a blank here, and I'll explain what these blanks do. So this is our step 1. Step 2 is half of b and square it. So this negative 4 is now our b value. Because we GCF'd out that 3, our b value is kind of changing within the problem. So we're going to take half of negative 4 and we're going to square that. So half of negative 4 is negative 2. Squared is 4. And that goes in that blank right there. Okay, I call step 3 compensate, because that word really helps you remember what it is that you're doing. To compensate is like to balance something out. In math, when we say you're solving for a variable, if you have to subtract something, you don't just subtract it from one side, you subtract it from the other. That's a balancing act. So this plus 4, you can't just add 4 into an equation without compensating it later. But furthermore, this plus 4 is going to get multiplied times this 3 that was out here, because if you were to FOIL this, this plus 4 would actually become plus 12. So here I have added 12. So this is going to be your compensation blank. And on one side of the equation, I added 12. On that same side of the equation, in order to compensate, I need to subtract 12. Okay, and so our step 4 is going to be putting it into that vertex form. So step 4 is a x minus half b squared plus k. I'm going to move this up. And I'm just rewriting the problem because y'all can't. Okay, so my step 4 is y equals. My a is still 3, open parenthesis. Earlier, we took half of negative 4 and we squared it. But now, inside of that vertex form is not the squared part. It's just going to be half of negative 4. So that's x minus 2. And then you square it on the outside. It's not like you're actually going to square it. It's just that the equation is going to have that squared in it. And then 36 minus 12 is 24. So this is the vertex form of our equation. I'm sorry? What would happen if you FOILed this? You'd go back to the other thing. In fact, if y'all want to do this, I think it's important for you to understand that you have not changed the equation. You have simply changed the appearance of the equation, right? X minus 2 squared, if you took x minus 2 and you squared it, that would be x squared minus 2x minus 2x minus 4x plus 4. So this is x squared minus 4x plus 4. If you multiplied that times 3 and combined like terms with the plus 24, you would go back to your original equation. So it's not that we have changed this equation into something different. It's just that this is the same equation written using the vertex form. The benefit of vertex form is, of course, now I know I have vertically stretched it. I have gone right to and up 24. Whereas before, I wasn't sure exactly what that equation would look like. Yes?
So you don't have to factor each time. You can just do x minus 1/2 b, and that will get you that.
Yeah, but you have to kind of, in order to know what you added here, this step is necessary so that you can compensate with the correct number here.
Oh yeah, I was just wondering, like, we didn't have to factor x squared minus 4x plus 4 to get x minus 2.
No.
Okay.
No, it'll always just be half of that b value.
Okay.
I see what you're saying now. Okay, let's go on. It takes a lot of practice, but after you get it, it's just some steps that you follow to get it into a different form. So, A, what we're going to do is with the first two terms, you're going to GCF out -2. You're going to put in a blank, then the 13, and then the blank. So, -2, open parentheses. -2 times x squared, and then -2 times, if I have to multiply to -12, I already have the negative sign, so plus 2 times 6x plus blank. Then I have still the -13, and this is going to be my compensating blank. So that's kind of like your step 1. Your step 2 is, what do you put in this blank? So we take half of 6 and you square half of 6. So half of 6 is 3, squared is 9. But for a compensation blank, don't just think of 9. You have to think about this 9 is going to get multiplied times -2. So this represents -18 here. So if I want to compensate -18, I need to add a regular 18. That would make this -18 plus 18 balanced out. So plus 18. If you want to put a little positive sign just to say, yes, I did make sure I'm doing the correct form there.
Can you say what kind of 18 again?
You understand where I got the 9?
Yes.
Okay. This 9 is going to get, because it's inside of the parentheses, it's going to get multiplied times -2. So -2 times, yeah. All right. Now we have the actual form. So the A value is still -2. And then what I like to do is, so that I can just kind of keep this in mind, half of 6 squared is what went here. But what's going to go in this part is just the half of 6, which is +3. And then I will square that. And -13 plus 18 is +5. So this is +3 squared. So this is the vertex form. So we would know I would reflect it, I would stretch it, I'd move it left 3 and up 5. Okay? All right, let's do one last example. All right, so my first two terms, I'm going to GCF out -1/2. So -1/2, open parenthesis. So I have -1/2 times x squared. This next part's difficult. Think about, first of all, if I have a +5x and I have a negative here, I need to multiply times another negative to get positive. Half times what is 5? 10. So -10x plus, this is my blank, -7 plus blank. Okay, so what goes in my first blank is half of -10 squared. So half of -10 is -5, and then I square it is 25. But what did I really add to this side? So I really did -1/2 times 25. Well, half times 25 is 12.5. So -12.5 is what's on this side. So I need to compensate. If I subtracted 12.5 here, if I subtracted 12.5 here, I need to add 12.5 to compensate that. Okay, so we have -1/2. X, and then half of -10 is -5. Then I square it. -7 plus 12.5 is +5.5. You followed where I got the 25?
Yeah.
This 25 is going to get multiplied times negative 1/2. So negative half times 25 is negative 12.5. I compensate negative 12.5 with positive 12.5. Okay, so this is our vertex form. Any questions?
That's cool.
Okay, let's go on. The discriminant. The discriminant is part of the quadratic formula. If we talk about the quadratic formula, is negative b plus or minus a large square root b squared minus 4ac all over 2a. That's the quadratic formula. The discriminant is the part of the quadratic formula inside of the radical. So the discriminant is b squared minus 4ac. Since I'm talking about a, b, and c, I'm back to the standard form, right? ax squared plus bx plus c. Those are those letters I'm using. So the discriminant could be a positive number, greater than 0. If the discriminant is a positive number, when you take the square root of it, you get a regular number. And so I'd have negative b plus or minus that number. So that's going to end up in plus that number and minus that number. This would give me 2 answers. Okay, b squared minus 4ac. If you plug in those letters, and you get the answer of 0. Then when you do negative b plus 0 or negative b minus 0, that's still just negative b. So you would only have one answer here. And then b squared minus 4ac, I'm going to erase this thing. No, I'm not. Could be less than 0. Look at where that b squared minus 4ac is. If it's inside of the radical and you get a negative number inside of the radical, we've talked about what do you actually call negative radicals?
Imaginary.
Imaginary. So this would result in 2 non-real answers. Or you could say 2 imaginary. I'd accept that too. So either 2 imaginary numbers or 2 non-real numbers. So let's practice that. If this is my equation, I'm going to rewrite that. And when I rewrite that, I'm going to write it in the correct A, B, C order. So negative 2x squared comes first. My x term comes next. That's a positive 3x. My c term comes last. That's plus 1. So my a is negative 2. My b is 3. And my c is 1. So the discriminant, b squared minus 4ac, if I plug in b of 3, I square it, minus 4, a is negative 2, and c is 1. 3 squared is 9. 4 times negative 2 is negative 8, but I have minus negative 8. Is that going to be a positive or negative number? Positive. If you want to say, well, that's 17, you can say that, but really you don't have to know what the number is. You just have to know, well, that's going to be greater than 0. And when I have something that's greater than 0, I would have 2 real solutions. Or just 2 solutions I would accept. You don't have to say they're real. It's implied. So the answer is not 17. Keep that in mind. The answer is there one answer two answers or two non-real answers.
We're not going to find those actual solutions.
We will find the solutions, just not for a while.
I'm down with that.
Any questions?